Hey guys, welcome. This is our 2.6 video. It's called Proving Angles Congruent, and today we're going to prove and apply theorems about angles. Okay, again, proofs are very simple. They are just showing how we know something. Alright, well, our first definition we come past is what's called a theorem. We haven't got a theorem yet, but a theorem is a conjecture or statement that you can prove to be true. So we talked about a postulate. A postulate is something that we know to be true, and it's a given, and we just accept it as fact, okay? And then a theorem is a conjecture statement that we can actually physically prove, and there's a proof for each one, okay? So I'm going to actually show you that real quick. We're going to take notes on the vertical angles theorem right here as well. So go ahead and write this box down, and this just states that if we have vertical angles, that they are congruent. So 2 is going to be equal to 4, and 1 is equal to 3. So if you need to, pause the video. I'm going to show you that there's a proof to this. So 1 second. Okay, do not write this down, but here's the proof. How you can prove two angles are congruent. Okay, it goes through a lot of different steps, a lot of different things, but there is a proof of why this theorem is accurate. And again, theorems are always proved. Okay, that's why we actually learn about proofs. You don't have a theorem without having a proof to back it up. So here's the proof for the theorem. Again, don't have to write this down. Okay, let's get some more theorems. Okay, so we already went over this theorem. Now we need to go over this theorem and kind of cutting it off a little bit. Let me see if I can adjust this slightly. There we go. And this is called the congruent supplements theorem. So write all this down. You're going to write all these boxes down. There's a few of them. If two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So 1 and 3 are supplements, 2 and 3 are supplements, thus 1 and 2 are congruent. Basically 1 plus 3, right, makes 180. 2 plus 3 makes 180. That means 1 and 2 have to be the same angle measurement. Okay? We have the same exact theorem, but for complements. So instead of adding to 180, we're going to add to 90. So you want to write this box down. And then all right angles are congruent. So this is actually a theorem. We just call it right angles theorem. It's fine. We can just write all right angles are congruent. 1 and 2 are right angles, then I know that they're congruent to each other. And if two angles are congruent and supplementary, then each is a right angle. Okay, a lot of writing theorems down today, and I do apologize, but you'll see why. So two angles are congruent and supplementary, then each is a right angle. Okay, so 1 and 2 are congruent, 1 and 2 are supplements, then we know that they're 90 degrees. Okay? And that's all the theorems we're covering right now. Let's go ahead and look at a couple examples. Okay, so our first example here is finding the value of x. Well, these are vertical angles, so all I have to do is go ahead and set them equal to each other. So 3x equals 2x plus 40. Again, this is not a proof. We're just using the theorem to help us set up and solve an equation. Subtract 2x from both sides, we end up with x equals 40, and that was it. So make sure you write that one down. That was a really easy problem 1. And there's someone out there that says I lack enthusiasm. You know what? That's just rude. I have a lot of enthusiasm. I mean, I'm super enthusiastic. So this next problem, I'm going to put on my enthusiasm. Alrighty, let's do this. Example 2. It's our last example. Okay. Use the vertical angles theorem to prove the following. 1 is congruent to 2. Prove that 1, 2, 3, and 4 are congruent. Okay. We're going to do a 2-column proof. Statement. Oh yeah. Love a statement. Followed by a reason. Ta-ta. Ya-ta-ta. Sha-ta-ta-ta-ta. Alright, number 1. We usually like to start with what's called the given. Angle 1 is congruent, to angle 2. How do I know this? Given. Yeah. Okay, let's stop, let's pause. Okay, before we just jump through and try and solve this, we want to think for a moment about how am I going to do this. if 1 and 2 are congruent, what does that mean about 1 and 2? Well, 1 and 2 are a linear pair, so these are probably 90. And I know 1 and 3 are congruent because they're vertical, so that's 90. So basically, all these angles are 90 degrees. So I got to somehow explain that. So that's what my goal is. So I think my first job would be to show that maybe 1 is also congruent to 3 or something like that. So let's try that. All right, back into my enthusiasm. Hey, all right, number 2. So 1 equals 2. I need to show it also equals 3. So guess what? 1 does equal 3 because of, you got it, they're vertical. Vertical angle theorem. We can write theorem with T-H-M. Okay? So now I showed 1 equals 2 and 1 equals 3. Now I need to show that 3 also equals 2. Well, this would be also true because of transitive property. Angle 2 is congruent to angle 3. Notice 2 is equal to 1, 3 is equal to 1. So guess what? 2 and 3 are equal. That's called transitive property. Yay, transitive. I have the spelling. I don't know how to spell that word correctly. Sorry. No. Yay, transitive. It's really hard to write on here sometimes, and I don't know why. I need to get a better one, maybe. All right, step 4. Show. We've showed 1 equals 2 and 2 equals 3. Now I need to somehow show 3 equals 4. But I can't get there yet. First, I got to show that 2 equals 4, because they're what? Vertical angles. 4 vertical angle theorem. Yeah. Well, I want to show that 3 equals 4 because I showed 1 equals 2 and I showed 2 equals 3 and I need to show 3 equals 4. How do I do that? Well, what I would do is I would go ahead and use transitive property, because if 3 equals 2 and 4 equals 2, guess what? 3 equals 4. Booyah! So epic right now. The epicness is unreal. Transitive property again. Why are you so crazy? Transitive prop. Move my face. Whoa. Wow. Okay. And I think that's pretty much it. We showed all those lovely pieces. They all kind of equal each other. So sticks. It's true that 1 equals 2. We showed that here. 2 equals 3. 2 equals 3. Showed that there. And 3 equals 4. Showed that there. And again, 6. That's just repetitive of transitive property again. So booyah, we finished. We're the best. We look awesome. And we're the best. And that's the end of the video. And I'm out. Alright, hoods up. Yeah. Ow. We out. We out. We out. We out. Okay, I don't know how to get out of here.